Let's start the class, please.
Maya, good morning. Jotam, good morning. Everyone, good morning. So last class we were discussing about one very important thing. Elevation, good morning. Sharmila, good morning. Maya, present or not? Okay. See, last class we were discussing about yes, last class we were discussing about one very important thing, and that is we wanted to know about is the screen coming okay? Yes. So we wanted to know about how the circuit look like. Okay. In that, when we were studying, we learned a very important thing, and that is about current. In that situation, we had learned two important factors related to current. Name, you need to call out your name, please. So then only I'll be able to take your name. So see, in the current, when we were understanding, we understood that the net flow is coming as zero. Another important thing, there was a drift velocity. Can anybody explain what is the meaning of drift velocity? Because the moment we were studying drift velocity, we learned a very important thing that whatever electrons that is moving from the negative terminal. Good morning, Mahalakshmi. Yes, beta. Good morning. Come fast. Anu, good morning. Sophia, good morning. Yes. So we learned a very important factor there. The most important factor, what we have learned there is that we'll do one small recap. Then it will be able to we'll be able to understand. So here, semiconductor, conductor, insulator, we have studied. But the most important thing, what we started and we learned there is Tarun. Good morning, Tarun. Is it Tarun? Yeah, Jasmita, Sophia, good morning. So now look here. So what when we were studying, we understood a very important thing that the ions are present. How the ions are formed? Because the atoms are leaving the outermost orbit electrons. So once they are leaving the electrons, what they are making? Ions. And these electrons, they are moving in zigzag motion. Understood. These electrons are moving in what motion? Zigzag motion. And then what is happening there is, when these electrons are moving in zigzag motion, computer Sarna, good morning. So when these electrons are moving in zigzag motion, from nearby going means if it will hit means the class will be over. Okay, so zigzag motion, if it is moving beta, then when potential difference is generated, means addition of cell or a battery in the circuit, what will happen? A potential difference is generated. A negative terminal and a positive terminal is formed. So negative terminal and positive terminal, once they are formed, what is exactly happening is the current will start moving from negative terminal to positive terminal. See, the electrons start moving from negative terminal to positive terminal, and the conventional direction of flow of current is positive terminal to negative terminal. Conventional direction of flow of current is from which terminal to which terminal? Say fast. Positive to negative. Positive to negative. This is exactly something we need to. Yes, positive to negative. Positive to negative. So now that was that important content we have studied. A conductor or a wire carrying current is always neutral. Understood? Neutral. Good morning, Devya. The conductor or wire conducting, see, a conductor or a wire carrying current is neutral. Its net charge is zero. Its net charge is exactly what? Zero. So this is most important thing. Its net charge is coming as zero. What happened here is कि positive to negative is absolutely correct. Its net charge is coming as zero. So this is some things we need to understand. Okay, so we have studied till here insulator, semiconductor, conductor we have studied. Now also the flow of current, direction of motion of current also we studied. Now we are going to go to the Dhanushya. Good morning, beta. Very good, Dhanushya. Now this is what I was wanting. You are very punctual and you are coming in classes in time. Very good. So this is what is needed, beta. Now look here. Last class we talked about electric cell. Electric cell means only one plus and one minus. This is presenting what? Electric cell. The second part what we have understood is combination of these electric cells are called as battery. So batteries are exactly combination of electric cell. Next one, plug, open and closed. Wire, we understood the junction. Junction means there are two different type of junctions. One is exactly open and one is closed. So this is connected one. This is connected one. And here what is galvanometer? Galvanometer is that, good morning Ashwita, good morning. So yes, a galvanometer work is what? To checking the amount of induced current. Induced. What is the word? Correct word is induced. Induced means what? Induced means the current that is possessed inside the circuit. Understood? Inside the circuit. Not because of maintaining potential difference. It is not because of maintaining potential difference. So here potential difference is not maintained. Actually, what is happening? Disturbance in the circuit is exactly allowing the current to move. That is exactly called as what, beta? Galvanometer. So induced current will be happening at the time, yes, at the time everybody start answering the questions. At the time when we are doing what? We are trying to find what? Tell me. Induced current, galvanometer moves and exactly shows that the induced current is present there. The galvanometer shows and present that the induced current is present there. Okay, now we are going to talk about wire crossing without joining. This is what? Wire. Krish, good morning, beta. Wire crossing. Good morning, Himanshu. Wire crossing without joining. See, this is not a joint, but previous one was a joint. So that was the difference. Now here, heater. So you will be seeing that this is exactly the symbol of heater. Now next part is electric bulb. The symbol of electric bulb, tapping key also we have studied. This is what? Fixed resistor or variable resistor? Fixed resistor. So fixed resistor resistance is fixed. Fixed resistor resistance is fixed, and that was a tapping key. Now this is variable resistor. We have talked about ammeter and voltmeter. What is the difference between ammeter and voltmeter? And your time starts now. If somebody has to explain about, if somebody have to explain about voltmeter and ammeter, what they're going to talk about, who is having maximum resistance? I'm asking everybody, first check you are live or not. Satya, good morning, Satya. Come on, children, everyone, start. Variable resistor is also called as rheostat. Yes, very good. Super. That's what I was wanting. Very good. Super. Both of you have given the two solid points. What about the other children? Voltmeter has high resistance. Yes. But answers are coming late. You have to be very fast. Voltmeter is having high resistance. Super. What about the next point? Come on, say the next point. Ammeter are low resistance. Ammeter are having low resistance. Absolutely. So what is the difference between having high resistance and low resistance? What and all things are there that is associated with high resistance and low resistance? That you need to answer me. Loud. I can't hear you. Which is carrying current? Voltmeter carrying current. High resistance means low current or more current? You need to say. High resistance means low current or more current? Current. Online children started answering. Now look here, they what you said, online kid children are not accepting. What they're doing is they are writing answers very fast. They are writing. Yes, absolutely. Jotam is not agreeing your points. Jotam has given some answers. Fine, I'm going to start numericals. Get ready for numericals. Now look here. So what is exactly given here is we'll start differentiating between voltmeter and ammeter. Voltmeter ammeter differentiation is very, very important. Absolutely correct, everybody. So first point, what is exactly the difference we are going to voltmeter and ammeter. So first voltmeter will be written like this, plus and minus. Ammeter will be plus and minus. That voltmeter and ammeter, very good, super. High resistance, very good, Imanshu, super. So now here, this is voltmeter and ammeter. It is exactly connected in parallel, and this is connected in series. Understood? Its work is to find potential difference. Its work is to find current in the circuit, amount of current flowing in the circuit, amount of current flowing in the circuit. Its work is to find the amount of current flowing in the circuit. Its work is to find potential difference generated across the terminal. Its work is to find the potential difference generated across the terminal. That's the work. It has high resistance. It is having low resistance. Understood? Less current flow. More current can flow. So easily we can trap out the four differences. That's the most important thing. In very shortcut way, in a very, very simple way, we can differentiate in board examination. When I'm starting the what you call the training sessions, at that particular time when I will start the training sessions, at that time I will tell you how to write less and how to bring more. Understood? Ashish, good morning, beta, you're late. So now look here. This is exactly voltmeter is connected V. It is written as A. Symbol is this one. Parallel. This is connected in series, and this is connected in series. Its work is to find the potential difference. Its work is to find the amount of current. It's having high resistance. It is having low resistance. It's exactly less current flow, and this is more current flow. So here current can flow easily, but here current cannot flow easily because it is having what resistance? High resistance. Come. So it is having high resistance. So that's the difference between. So that's the difference. Okay. I hope everybody understood this one. Come on, come on, come on, children. Thank you for liking the class. Good morning, everyone. Yashwit is not there in the group. This is exactly Himanshu is there. So now less current flow and this is more amount of current flowing in the circuit. Okay. So this is exactly the content what we known about voltmeter and resistor. Okay. Okay. He's asking question. Are you all ready? So now we are going to talk about, thank you, Beta. So now look here. Now we have to see the circuit. Usually in CBSE, na, they will give you a wrong circuit and they will be expecting you to draw the circuit. Huh. So they will tell you to draw the circuit. So this is exactly what type of circuit. Wrong circuit rectification is also one of the part. Porani absent, Yashvit absent, two people absent, and they from there Vishwa absent, one Vishwa is absent. Oh, one Vishwa is absent. Yes, in house we are using parallel correction. Mobile and circuit both are different. We are going to discuss parallel and series connection. Very easily we will understand. I'll teach you in the very most simplest way. Now come on, we will do this one. This is circuit. This is exactly cell. This is what key. Is it closed or open? Closed. Very good. So current will flow or not? Yes. And it is what? Bulb. It is bulb. Current is flowing from positive terminal towards negative terminal. Electron is moving from negative terminal towards positive terminal. So that's the most important thing. Yes. So now we are going to go to the next point. Kavya is absent today. Kartika is absent. So open circuit and closed circuit we have already understood. So now we need to understand what is the meaning of electromotive force. So electric cells, so I hope everybody understood what is the meaning of electric cells. 1 minute. See, what is the meaning of electric? Parallel is connected. Now look here, electric circuit. An electric circuit is a device which maintain a continuous flow of a charge, continuous flow of charge in a circuit. Sorry, electric cell is a device which maintain continuous flow. Means in simple we can say that they are maintaining what they are maintaining a very important thing, and that is potential difference. Once the potential difference is maintained, exactly it is going to do what it is going to the cell changes chemical energy into electrical energy. Yes, so chemical energy will get converted into electrical energy. So where is the chemical energy taking place? The chemical energy is taking place in the cell. The chemical energy is taking place in the cell or battery, and that chemical energy will influence the circuit. That chemical energy is influencing what? The circuit. Okay. So now we need to understand, this formula is not needed, but you understand what is the meaning of electromotive force. What is EMF? What is the meaning of electromotive force? Maya, Praveen, Tarun, Satya, Ashish, quickly say me hi. Jotam is awake only. Jotam is there, he will answer. So now look here. So the work done by a cell in forcing unit positive charge to flow in the whole circuit once is called as electromotive force. Yes, Maya is there, Satya is there, Himanshu. Himanshu, I know you are active, beta. So that is not going to work. Those people who are not, I am calling out their name. Those who are not answering, I am calling out their name. See, Ashish, no response. Now look here, beta. So this is electromotive force. You need to understand one thing. The work done by the cell in forcing unit positive charge to flow in the whole circuit. So what we are doing here is Vishwa present. Two Vishwas are there. One Vishwa is absent. So now listen. Pay attention here. So yes, Tarun is present. You check your live or not. Everybody please check your live button first. People are answering very late. Now look here. So one thing is very, very important here is कि when we talk about electromotive force, so electromotive force is what? Electromotive force is a type of push. Understood? It's a type of force that is generated to kick the electron one time entire circuit. Understood? So it's just like I generated a force and I'm having some energy, and that energy I'm just pushing. With that energy, what I'm doing? I'm pushing you. Understood? And I'm allowing you to move throughout the circuit. That is exactly called as what, beta? Electromotive force. What it is called as? Electromotive force. It is just like, in simple, we are going to understand the work done by cell in forcing unit positive charge to flow in the whole circuit. The work done by whom? The work done by whom? Cell. Cell is having what type of reaction? Chemical reaction. This chemical reaction is releasing what? Electrons. This chemical reaction is releasing what? Electrons. And these electrons are doing what? These electrons are exactly aligning the electrons inside the conductor, and these electrons will move from negative terminal towards positive terminal. In a way, they are completing the circuit so that current will flow in the circuit. You need to understand like that. Understood? So what is the work done here is the work done by the cell in forcing unit positive charge to flow in the whole circuit. Unit positive charge to flow in the whole circuit is called as electromotive force. It is called as what, beta? Electromotive force. What it is called as? Electromotive force. The chemical reaction taking place inside the cell, it will exactly help the generation of electrons. These electrons will go from negative terminal towards positive terminal. And when it is moving from negative terminal to positive terminal, what it will do? It will generate a force. And that force will be exactly taken, unit positive charge is moving in the entire circuit. So this is called as electromotive force. Yes. Got it? So electromotive force will be exactly done. Now internal resistance. So we need to understand that. What is the meaning of resistance? In very simple, we are going to first understand what is the meaning of resistance. For you, according to you, what you are learning about resistance and what is the meaning of resistance. So first, we are going to understand resistance. So resistance is, in simple, you are saying, I resist going there. Resist means avoid. Correct now. What is the meaning of resistance? Avoiding. Ma'am, I'm avoiding. Yes, I'm avoiding. Avoiding means I'm not allowing to go to that place. So that is resistance. That is what? Resistance. So resistance is a type of Jotam. Seriously, Jotam is not responding. So now look here. So resistance. So resistance is exactly avoiding. Resistance is what? Avoiding. So if somebody will be trying to stop you, resistance is having two meaning. So see, the ions that is present in the circuit, they will also try to stop the electron to flow easily, correct na? Because the ions are made with atoms only na, and they are having electrons. So if they wish to move, electron are wishing to move from negative terminals towards positive terminal, will they be able to move? No, because they have to experience what? Resistance. What they have to experience? Resistance. Okay, come on children, everyone get ready. How can I convert a semiconductor into insulator? When can a semiconductor will behave like an insulator? Ay, 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 ay. Everyone, come on, answer the question fast. Let's see how many of you are sleeping. How many of you are sleeping? I know Himanshu. When it's, Jotam is telling, when it has more resistance. Jotam caught. Don't smile. You meet me, I punch you. Okay, it's not Jotam, it's Jasmita. Okay, Jasmita, huh? Jotam, morning. This is second time I'm calling you. Resistivity is more. Bah, suddenly everybody got silent. All went chat GPT. All went net. Hey, last class we studied. Say, no, miss. No, ma'am. Everybody is here. All obedient children are here waiting for me to answer the question. But everybody became silent. No chat GPT. That's very good. So now please pay attention here. You need to understand one thing. Thinking. Anu is thinking. I today I'll answer the question. So now look here. Sharmila, no, ma'am. What about Kavya? What about Kartika? All the idiots, their names, Elaversion, suddenly Elaversion vanished. Maya, now look here, that's good. So here, very good, Himanshu. Ma'am, oh, Elaversion is there. He's telling, ma'am, I'm here. So now, please pay attention here. The most important here is the semiconductor act as an insulator at low temperature, and the semiconductor act as a conductor when you will increase the temperature. That's what we have learned in last class. We discussed that when it is acting as a conductor, when it is acting as an insulator, low temperature. So when we will be wanting a semiconductor to act as a conductor, conducting devices, so what we are going to do, we will increase the temperature. So that's the most important thing. Come on everyone, tell me, understood or not? Maya, Ashish, Satya, Tarun, I hope you might have understood. Today, Praveen Gali. In school, he is Khali today. Seriously, I will give Kambal Kutai today to him. Yes, super. Those who will not call out their name, after that I will reach you now. My people will reach you because 90-day game we are going to start. So everybody please pay attention here. You need to call out, you need to answer. So now look here, next part. Yes. Jotam, third time I am calling your name. I have to message in group. Now look here, we are going to talk about some very important sections. The second section is internal resistance of a cell. When we connect the plates of a cell by a wire, when we connect whom? The plates of a cell by a wire, an electric current flows in the wire from positive plate of the cell towards the negative terminal. So from positive terminal to negative terminal, it is exactly going to flow. From positive terminal to negative terminal. From which side to which side, beta? Positive terminal to negative terminal. So this is something which we have to check about. Okay. So positive terminal to negative terminal. So now what we need to understand that an electric current flows in the wire from positive plate of the cell towards the negative plate, and in the electrolyte that is inside the cell, it flow from negative plate towards positive plate. So that is I'm going to explain this one. The resistance offered by electrolyte of the cell to flow current through is called as internal resistance of the cell. So that's the most important thing. What is the meaning of internal resistance of the cell? So you need to understand, Kavya punch you. So now that is called as internal resistance of the cell. What is the meaning of internal resistance of the cell? Let's check this one out. Okay. So internal resistance we are going to understand. So see, first thing we are going to draw the circuit. Kartika is still missing. So this is beta. We joined like this. Okay. Now we are going to talk about only one. We are going to talk about only one cell or battery connecting a wire. So this is exactly the plates of a battery. This is positive terminal and this is negative terminal. So when we are connecting it with a wire, Now when we are connecting it with a wire, okay, what happened? What happened to Kartika? Kritika. You are Kritika. Then where is Anu? So now look here. So this is connection. So this is positive terminal and this is negative terminal. Okay. So now this is positive terminal and this is negative terminal. So you can see that the electrons are exactly going from this direction negative. Okay. So it is going from here. This is the channel, we can say. That is what they're telling. In simple, this is exactly there. What you want to say, Anu? So this is exactly the simple thing. This is going from positive to negative, negative to positive. So this is exactly the flow what we are expecting. Understood? And that is what they were trying to say. What they said, let's check this one out. They said a very important point. They said that when, see, in a conductor, whenever current flowing takes place, the motion of electrons takes place. During motion, they are, that is internal resistance. So when we connect the plate of a cell by a wire, an electric current flows in the wire from positive terminal to the negative terminal, and in the electrolyte, it flows from negative towards the positive. So current direction they are talking about. Oh, Kritika. Okay, Kritika. So inform Kritika that ma'am is going to punch you. So now here it is exactly called as, so internal resistance. So it's about current. It's about current what we were discussing about. What we discussed is, can electric current flows in the wire from positive terminal towards negative terminal. Inside the cell it is moving from where to where? Negative to positive. So current direction we are talking about. Electron direction is from negative to positive. Current direction is from positive to negative. Got it? So current will flow from where to where? So whereas we are going to talk about current direction. So this is exactly the flow of electron. The electron will be moving from where to where, beta? Negative to positive. Negative to positive. And inside the cell positive towards negative. But when we talk about current flow, let's, blue color is current flow. So current flow will be in opposite direction. This is current flow. Current will flow from positive towards negative, positive towards negative, positive towards negative. Inside the cell, where from where it is moving? Negative to positive. Negative to positive. So that is exactly the thing. Now we are going to go for the next one. So this is about internal resistance. So internal resistance part we have understood. Now terminal potential difference means till it is connected to cell or battery, what will happen? It will have current in the circuit. So once the cell or battery will get discharged, will it induce current? No. Will it will have current? No. The answer is no. So now electrical resistance is also one of the most important thing. Now we are going to solve question related to current. But before solving question related to current, yes beta, that's absolutely correct. But before starting question numericals, we need to understand one very important point. About current we are going to understand one thing, and about resistance we are going to understand. Because with resistance only we will be understanding series and parallel connection. Okay. So now look here. So this part is electrical resistance. When somebody will talk to you about electrical resistance, before that, terminal potential difference. What is the meaning of terminal potential difference? How many cell or battery you are connecting, that much potential difference you are generating. Until that much time, the current will flow in the circuit. One cell means capacity is less, more will be there means the capacity will be more. That's something very, very important. Now look here, electrical resistance. In a conductor, whenever current flow takes place in the motion of electron takes place. During motion, they are opposed to flow and it is known as electrical resistance. Understood or not? So at the time when they are trying to flow, at the time when they are electrons are trying to flow, they are facing what? Opposition. What they are facing? Opposition. That opposition is electrical resistance. That opposition is electrical resistance. That is what I explained. The opposition part is nothing but electrical resistance. I hope everybody might have understood. So come on, we will go and start our work. So before starting resistance, let's write about the current. Okay, so now some things about current we are going to understand. So write a question. Yes, Kavya, opposition, super. Thank you for liking the class, children. So now we are going to solve this part. Write a question. A flash of lightning. A flash of lightning. Everyone start solving. A flash of lightning carries 10 coulomb of charge. 10 coulomb of charge, which flows in which flows for 0.01 second. How much time? 0.01 second. What is the current? Now you have to find the current. What is the current? What is the current? That is the first part of the question. Now, if the voltage is, what is the current? Come on, this is the most easiest question we can expand. Now, come on, start solving the question. What is the current? Only simple question I have asked, because this is totally depend upon the formula. This totally depends upon the formula. Just solve it. It totally depends upon the formula. Come on, start solving the question, please. So this is what a lightning flash of lightning carries. How much seconds? 0.1 second. What is the answer? 1000 ampere. 1000 ampere. Very good. So here the flash of lightning current charges. How much charge is there? What is the formula of current? Who can say? What is the formula of current? The formula of current is denoted by I is equal to Q by T. What is the 10 coulomb? Time is how much? 0.01. So coulomb per second. So it is coming as ampere. 2 0 cancel. It is coming as 100. So it is coming as 1000 ampere. It is coming as how much ampere? 1000 ampere. Absolutely correct. It is coming as what? 1000 ampere. This is the correct answer. We'll go for the next question, please. Yes, I is equal to Q by T, and it is considered as how much? 1000 ampere. Absolutely. I is equal to Q by T is the correct formula. So, right, if the amount of electric charge passing through a conductor passing through a conductor, if the amount of Porani, are you there? Miss, hard question. Punch you. Started how I'm going to give. First, let them. A high name is difficult to say. So now look here. So if the amount of electric charge passing through a conductor in 10 minutes, you need to find is 300. Okay, it is 300. How to take your name? You should say your name. So what is the current flow? Solve this question. First, you need to write your name. I'll take your name. Huh? 30. Yeah, you need to change your net because see, 30 minutes, 10 minutes are there. So 10 minutes means 1 minute is equal to 60 seconds. Yeah, 1 minute 30 ampere. Nice. So 1 minute is equal to how much? 1 minute is equal to 60 seconds. So 10 minutes will be 600 seconds. 10 minutes will be equal to what? 600 seconds. So now look here. Here when you are writing the formula, I will be equal to Q by T. So when I will be equal to Q is how much beta? Charge is 300. And time is exactly coming as what? Time is 10 minutes. So 10 minutes will be converted into seconds means 10 into 60. 600 is coming. So how much it is coming? Current is coming 300 by 600. Cancel 1 by 2. So 0.5 ampere. Where is that boy who was telling hard question I need? Still no, I didn't got the answer. Yeah, 0.5 ampere is the correct answer. Late answer. 0.5 is the correct answer. Understood. So this is exactly about what we have studied. We have studied about the current question, potential difference question. Also, we have solved. What is the formula for potential difference, children? Come on, write down and show me. What is the formula for potential difference? The formula for potential difference is Sarvana. Good morning. What is the formula for potential difference? Formula for potential difference. V is equal to, wow, potential difference formula is V is equal to R by E. I'm just not talking about Ohm's law. I'm just talking about potential difference formula. Potential difference formula is what? Potential difference formula is this one. V is equal to W by Q. This is potential difference formula. Current is equal to Q by T. Can we generate some relation between these two? Yes? Very good, Satya. So V is equal to W by Q is equal to there. Q is equal to IT. That we are going to do. Here Q is there now. So amount of charge will be equal to IT. That is VIT that we are going to generate afterwards. Yes. Wow. Nice. Now only I am seeing Ashwita. Very good, Ashwita. So now this is exactly V is equal to WIT. That part we are going to study heat when we are going to understand Joule heating effect. That time we will do. But what is the formula for potential difference, Jivita? Very good. Current is equal to Q by T. Very good. Current is equal to Q by T. So now let's start our resistance work. Okay. Now resistance, once we are going to finish, our work will be easy. We will solve big numerical circuit resolving we are going to study. Okay. So now let's start this work, Peter. So now, what are the factors which is affecting the resistance of a circuit? So what is the meaning of resistance? What is the meaning of resistance? If somebody will be asking you, what is the meaning of resistance? Then your answer should be the thing that is exactly resisting the flow of current. Something which resists the flow of current is considered as resistance. Now, one question I am going to ask from all of you is a bulb resistance or a resistor resistance? Which one is resistance? Very good. So the answer is obstacle to flow of current is exactly called as resistance. Yes, absolutely correct. Very good. Tushar, absolutely correct. So now we need to understand the flow of current is there. See, I'm going to discuss some of the most important points. See, the first important point is if somebody will be talking to you about conduction of current, you will be saying that the current will be exactly present in the circuit because of potential difference maintenance. Correct now? Till you will maintain the potential difference, till then current will flow in the circuit. That's one thing. Okay. Now it totally depends upon how much cell or battery you are connecting. That much also is very important. I want to glow 10 bulbs and I put 2 cells. Will it work? No. It is not going to work first. Why it is not going to work? 10 bulbs are there and 2 cells are there. It is not going to. We need to increase the amount of potential difference so that the energy utilized should be heavy. The energy utilized should be heavy. Everybody, thank you so much, beta. So now listen. So now what work we are going to do here? We are going to understand, but in this process, we need to understand one more important point. See, when the current is exactly flowing in the circuit, the amount of current is important. Correct. Second part is potential difference is important. Potential difference is important. That means something is there related to current and potential difference. Something is there which is related to current and potential difference. Let's try to realize that part. So resistance, they are telling resistance part is there, but before resistance we must understand Ohm's law. And what is exactly Ohm's law, beta? What is exactly Ohm's law? Shall we start Ohm's law now? So now we are going to understand Ohm's law. See, but one thing is there, please understand, Ohm's law will be applicable at constant temperature. See, current fluctuation, Ohm's law avoid. Got it? So here one big restriction is there, ki we will be, a very nice funny face. So we will be trying to understand one very important thing, that ki when somebody will be asking you Ohm's law, you will be saying that the most important restrictions of Ohm's law is at constant what? At constant temperature. Absolutely correct, Tushar. It is V is equal to IR. But V is equal to IR when? Because we know one very important thing. Current and see, V is equal to IR. V is directly proportional to current. Current is directly proportional to V. This is exactly the relation, and that's what the word what I said now. Given amount of current flowing in the circuit depends upon what? Potential difference. That's what is a simple concept now. Very good. That's what is a simple concept. What's the simple concept is? Okay, if somebody will asking you, okay, how much cells I will apply, I will put in the circuit so that I can be able to glow 5 bulb. Then you will say, A, 5 bulb means we have to maintain potential difference and we have to apply more cell. That time kuti cells are not going to be used. Understood or not? But that Deepavali, you are putting that lightning lamp, that light, what you call that decorative items you are putting. For that, you will see that that kuti, that pencil cells are there. Na, that is exactly enough. There will be combination in that and they will glow for hours and hours. So that means what? We have to understand that how much watt power means how much current they are taking, that much amount means that much preparation has to be done na, for letting it glow for long time. Correct? So that means there must be some connection. There must be some connection. So very good, Kavya. Krish, are you ready? There must be some connection. So that connection is what? That connection is potential difference and current connection. If more potential difference will be there, that means more amount of current will flow in the circuit. So that means potential difference is directly proportional to current flowing in the circuit. If I will generate a more potential difference, it will have more capacity to allow more bulb to get glowed. Understood? That's the simple. Yes, Vishwa, I know, beta. So here, this is exactly the concept. I hope everybody might have understood. What is the concept? More potential difference will give you what? Yes, more potential difference will allow more bulb to glow. More potential difference. So that means potential difference, absolute beta. So potential difference, Maya, did you understood? Ashish, did you understood? Ashish, today you will get nice beatings. So just wait and watch. Done? So beta, this is called as proportionality. This is exactly, yes. So about current information is correct. So potential difference is directly proportional to current flowing in the circuit. Understood? More potential difference, more current can flow. But how can we make it equal? See, proportionality is not equality. I am saying I am proportional to you. Means when your age will increase, my age will increase. Correct now? That means what? My age and your age increment will be there when we both are what? Proportional. So that means what? So all human beings means their age is proportional. Directly proportional or inversely proportional? Directly proportional. Why beta? Because if my age will increase, your age will ultimately increase. That is called as direct proportionality. What it is called as? Direct proportionality. But is it equality? No. Is it equality? No. So how to make it equal? So when we will put some constant, it will become equal. So what is R? R is called as constant of proportionality. R is called as what beta? Constant of proportionality. So whenever any inequality, any what you call this part, we are making it equal to current, this is exactly added. So one, when we can make it equal, when constant of proportionality is added. When constant of proportionality is added. Absolutely correct, everyone. When what is added beta? Constant of proportionality. When constant of proportionality we are going to add, then only the equation will become equal. Otherwise it will always be proportional. So what is the work of R? Now we have to understand what is the work of R. R is why we are introducing R. You will say R is constant. It is maintaining. It is maintaining. It is making things equal. So if right now my age is 30, your age is 10. Understood? That means how much we have to back up? 20 we have to back up so that we both will become equal. So that backup part to make things equal is what? Everybody understood? Come on, say everyone. Understood or not? Everybody understood now? So that is exactly the work of proportionality. The work of proportionality is maintaining the circuit, making things equal. So potential difference is directly proportional to, absolutely, I hope everybody might have understood. Nitya, sorry, Dhanushya, yes, constant of proportionality. So you need to understand. So R is exactly called as what beta? Constant of proportionality. Then why R is called as resistance? Why? Resistance is, listen very carefully. What is resistance? Resistance is restricting the current flow, is resistance. But why we are adding resistance here? We can say resistance is the natural phenomenon of every conducting device. Resistance is the natural phenomenon. Resistance is natural for every conducting device. But why we have added resistance here? What is the need of adding resistance? Why we call it as resistance when we understood what is the meaning of electrical resistance? What is the meaning of electrical resistance? We understood. But why we are adding resistance here? Come on, all the genius fellows, think and say. Very good. That is tech. It is good. It is limiting the flow of current. To limit the flow of current, but limiting the flow of current, resistance is added. That's the super answer. Super. But here why? V is equal to IR. Here why? To balance the flow of current. Whatever you say, for understanding, you are generating an idea. That's a very good thing. To balance the flow of current, the voltage depends upon the resistance and the amount of current. See, you need to understand one thing. Resistance is the intrinsic property of the material. One thing. Resistance is the intrinsic property of the material. If I am going to use copper, the resistance will be different. If I am going to use, now that is the intrinsic property of the wire first. Got it? Now wire is connected to what? You need to understand it very, very technically. So technically, if somebody will be telling you, you will say first ki wire is having its own resistance, which is exactly coming as resistivity, which is coming as what? Resistivity. This is the first point, ma'am. Second point is, if I want to maintain the flow of current in the circuit, I will put resistors. That is what tech has told. So that is, resistor is exactly what? To maintain the flow of current in the circuit, we are adding extra resistors. Understood? Because all the conducting devices, resistance is exactly not same. Like if I need silver wire for conducting, or I need copper wire for conducting, so definitely the resistivity of both of them are different. Understood? So silver wire will have less resistivity, but copper wire will have more resistivity. I hope everybody might have understood this one. Got it or not? So wire is also giving resistance. It's not like wire is not giving resistance. The wire which is carrying current is also giving resistance. So here, why we have utilized, why we have written V is equal to IR? You need to understand. So here, potential difference is directly proportional to I, current is directly proportional to potential difference. But we have learned a very important point, and that important point what we have learned is during the course when the potential difference is maintained in the circuit, the electrons are flowing. The electrons are going what? They are flowing. When the electrons are flowing inside the circuit going from negative terminal to positive terminal, the ions that is present, the atom, see copper atom, just simple example I'm taking you, I'm giving. So this is the copper atom. Now copper atom last most orbit 2 electrons were there. These electrons dished copper and went out. So now copper ion is 2 plus. Understood? So once the circuit is connected, what will happen? The current will start moving. Sorry, the current will start moving from positive terminal to negative terminal. The electrons will start moving from negative to positive. At the time when they will try to move, the electrons will try to move, the electrons will suffer collisions. The electron will suffer what? Collisions. Collisions with whom? Their own fellow beings or ions? Ions. The collision will be exactly between the electrons and these atoms. These atoms, what they have lost electrons, they will be exactly becoming an ion. So these ions will exactly stop the flow. Understood? So when these ions will stop the flow means here it's not complete flow stopping. It is exactly reducing the speed. So only what is drift velocity? Drift velocity is average velocity. What is drift velocity? Average velocity. Why? Because we cannot take the entire motion at once. Are you understanding this part? So this is the most crucial factor. See, current is not a rocket science. Current is totally depending upon what you have understood about resistance, what you have understood about the conducting devices. I hope you might have understood that one. So we are going to understand, okay, there are some intrinsic property of the conductor. Because of that, what is happening? Because of that, what is happening? The flow will be hindered. Understood? So that's why when we making it equal, we are talking about, see, when I want to make you equal to me, I will be talking about the downfalls. What and all are the downfalls? Resistance is the downfall, because resistance may not allow me to become equal to you. Are you understanding? So if potential difference is added, potential difference is generated in a circuit, not added, generated in a circuit. That means potential difference must be equal to current. But who is properly stopping here? Resistance. So we are making resistance as one of the thing that is present in the circuit, and when resistance is present, after addition of resistance, what makes me and you equal will become the equation. Are you understanding here? Are you understanding? So when resistance is one of the witness, so resistance into current means, because the current resistance will be the potential difference generated, but potential difference can only mean, what is potential difference is nothing but how much chemical reaction took place, electron moving. But what about the conducting device? What about the wire? What about the resistors connected to it? What about the bulbs that is connected to it? Are you understanding? So all of them will allow some resistance. So that resistance with the current should be equal to potential difference. That's the only point. I hope everybody understood this part of the video. Whenever you will have problem, na, just remember this part of the video. Are you understanding this one? So when V will be equal to IR, why IR we are writing? Because current with resistance must be equal to potential difference. But I will allow more batteries to connect. I will allow more batteries to connect. That does not mean that I can make it equal, because here the problem is resistance. So resistance should be fine. I'm going slow. Some people are telling I'm moving very fast. So what did I said? I said a very simple point. What was the simple point, beta? When can current will be equal to resistance? What is the situation? Very good. So current will be equal to potential difference when resistance is added which side? Why? Because the amount of current depends upon potential difference. Potential difference does not depend upon current. Are you understanding? So only V is equal to IR. It is not I is equal to VR. Correct now? Who depends upon whom? Current depends upon potential difference. How much current will flow in the circuit is depending on what? Depending upon potential difference. And that's the most important point. I hope everybody understood this one. Come on, children, say me. Did you understood this part? I hope everybody understood this one. Come on, say. Yes, 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 yes. Got it? So I think, yeah, in next class, if I will ask this question, you people will be ready to answer this question. Yes, 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 yes. I hope the class is very fruitful, understanding class. Super. So next class, we are exactly going to discuss some other things, yeah, connected to it. Bye everyone. It's time. Have a nice day.